Have you ever felt like you're just pouring information into your brain only for it to leak right back out? We all want to learn faster and remember more, but man, it often feels like such an uphill battle. Well, in this explainer, we're going to dig into the neuroscience behind why that is and figure out how we can start working with our brains instead of against them. Let's get right into it. You know the feeling, right? You're maybe an hour into a lecture or some training session at work, and you can just feel your focus slipping away. Your brain feels like a totally saturated sponge that literally cannot absorb one more drop of information. It's that feeling of staring at a diagram with arrows going everywhere, or just rereading the same paragraph over and over until your eyes glaze over. And the next day, poof, it's like it never even happened. Well, it turns out this isn't some personal failure. It's actually a fundamental design feature of how our brains are wired. To really get why this happens, we have to start with the core problem that every single learner faces, a bottleneck, and it's right in the middle of our own minds. Okay, so this bottleneck has a name. It's called cognitive load. The researcher who came up with the term, John Sweller, gave us this fantastic way to think about it. Imagine you're holding a really heavy dumbbell over your head. For a minute? Okay, you can do that. 10 minutes? Oof, that's getting painful. An hour? No way, impossible. That feeling of strain, that's exactly what your working memory feels when it's overloaded. It's not a sponge getting full, it's more like a muscle getting completely fatigued. So here's kinda how that information flows, or at least how it tries to. Every second, we are just bombarded with sensory stuff. A tiny, tiny fraction of that gets promoted to our working memory. That's the mental muscle we were just talking about, the bottleneck, where we do our active thinking. And only the stuff that successfully makes it through that checkpoint even gets a chance to be stored in our long-term memory. And that's the crucial point. When we try to push way too much information through that working memory bottleneck, the whole system just overloads. We get confused, we start to zone out, and yeah, we forget. Which brings up a pretty huge question. If our brains are so easily overwhelmed, how in the world do we ever manage to learn really complex things, like a new language or a whole new professional skill? Well, the answer is actually brilliant. You see, our brain gets around this bottleneck by using two completely different, but totally complementary systems for learning. Think of it like a neuroscientific tag team. So, let's meet the two players on your brain's learning team. First up, you've got the hippocampus. You can think of this guy as a quick draft notepad. It learns super fast, capturing specific events and facts right as they happen. But then you've got the neocortex. This is the slow, methodical librarian, carefully organizing everything into this permanent, stable library of knowledge. It is slow to integrate new things, but once it does, that knowledge is there for good. So how does information get from that temporary notepad to the permanent library? The process is called consolidation, and it happens mostly while we sleep. Yeah, while you're sleeping, your brain replays the day's events, and it gradually transfers the important bits from the fast but temporary hippocampus to the slow but stable neocortex. This is exactly why a good night's sleep after studying is so critical for real learning. Okay, so what does the super elegant two-system process actually look like in the real world? Well, maybe the best example is one we've all been through, how a baby learns to talk. It is a perfect case study in natural, brain-friendly learning. For a long time, researchers sought two separate things that help babies learn words: hearing a word all by itself and hearing a word repeated over and over again. The thing is, they were looking at them as two totally independent things, and they were missing the magic that happens when they actually work together. They missed what researchers now call an isolation repetition cluster. This is just a powerful, naturally occurring learning event. A caregiver isolates the word, fingers, which is perfect for that fast-learning hippocampus to just snatch it right up. Then they repeat it in context, giving the slow-learning neocortex the repetition it needs to start integrating that word. It's the perfect 1-2 punch for our two-system brain. So you'd think these perfect, brain-friendly learning moments happen all the time, right? Well, the data is actually kind of shocking. On average, only about 3.8% of the nouns a child hears are delivered in this super powerful cluster format. It's an incredibly rare event. And yet, even though they're so rare, these moments have a massive impact. Research shows that how often these clusters happen is a powerful predictor of which words kids learn first. It's not just about the quantity of words they hear, it's about these rare moments of really high-quality, brain-friendly input. Okay, so if nature has this all figured out, can we apply the same principles on purpose? Absolutely. This is where we go from just observing natural learning to intentionally designing it.
This applies directly to things like project-based learning in schools. An unstructured, go-figure-it-out project can be a total cognitive nightmare, but a well-designed one, that's brain-friendly. Instead of just saying, hey, build a model of a volcano, you first isolate the key vocabulary, like magma and eruption. You give them a clear step-by-step guide. You're actively managing their cognitive load, working with their brain's limits, not fighting against them.
And it's not just schools. The corporate world has caught on to this too, with a strategy they call microlearning. This is basically the adult, professional version of that isolation repetition cluster. It takes a huge, complex topic and just chops it down into short, focused, digestible lessons. And the difference between the old way and the new way is stark. The traditional approach is that cognitive nightmare, the full-day seminar that completely overwhelms your working memory and is pretty much forgotten by tomorrow. Microlearning is the brain-friendly solution. It gives you focused, just-in-time information that respects our mental limits, which makes it way more efficient and a whole lot more effective. So, after this whole tour of our brain's fascinating architecture, what's the big takeaway here? How do we use all this to actually become better learners? You know, the single most important thing to get is this. We've been thinking about learning all wrong. It is not a brute force activity of just cramming information against a wall until something sticks. Real learning is more like an elegant dance with our brain's natural design. It's about respecting the bottleneck of working memory and feeding both our fast and slow learning systems exactly what they need to thrive. So here they are, the basic principles for smarter learning. First, always manage cognitive load. Break complex topics down into smaller, digestible pieces. Second, feed your fast-learning hippocampus. Isolate the single most important idea first. Third, feed your slow-learning neocortex. Use repetition and apply that idea in a bunch of different contexts. And finally, consolidate. Honor the absolutely vital role of sleep in making those memories stick. Which really leaves us with a final, crucial question. In a world that's constantly changing, is the most important skill we can have not what we learn, but mastering how we learn? Understanding our own minds might just be the ultimate superpower. Thanks for watching.